All right, here we go. We're back. This is video number 1. The first video was number 0 because I was just testing this out. This is number 1. I'm here. My name is Billy. I'm solving some coding problems live on YouTube. I'll just be going through some Leetcode problems today. Yeah, I'll be talking through solutions, my thought process. You can see me like live coding and debugging and all of that stuff. And yeah, I think the plan right now is we're going to go through some easy questions for warm-up and then finish the daily challenge question. And then if there's time, we'll just do more stuff. So let's go for it. Are these sorted? Oh, this is just sorted by number of acceptances. Oh, we can't. All right, whatever. We'll just do these in order. Just for warm-up, we'll see what happens. All right, so we have running sum of 1D array. Given an array of nums, we define a running sum of an array as running sum at I equals sum of numbers from 0 to I. Return the running sum of nums. Given an array of nums, we define the running sum as, okay, so nums is that input. Oh, so we just return all the running sums. Okay, cool. Yeah, this, it's an easy question. It's a warm up. From right away, you can see that when you're looking at running sum at I, it's, let's say you already know that value, right? Then you have the sum of numbers from 0 to I. And then if you want running sum at I plus 1, that's like the sum of numbers from 0 to nums at 0 to I plus 1. But if you already know the running sum of the previous I elements, then you just have to take that sum and then add the I plus 1th element from nums. And then that gives you the running sum of at I plus 1. So that's pretty much how we're going to approach this problem. You can kind of go through and just build the running sum as you go. The memory here is just going to be ON memory of keeping track of the answer you're going to return. You don't need anything else besides that. Runtime is just single linear pass through this array. So let's code this up and see how we can solve this. Oh, let's also take a look at the constraints here. So we have length of nums is between 1 and 1,000, and the value of nums is just negative 10 to the 6 to 10 to the 6. So this nums.length, usually you kind of want to take a look at this for trying to guess what kind of runtime you need to solve the problem. Usually the constraints kind of inform what kind of runtime is acceptable. Here we just have end time. Definitely can do that on an array of 1,000. So yeah, let's do this. I think they have 1,000 here potentially to accommodate the very naive solution, which is for each element at I, you calculate the running sum from scratch, which would be like an n squared solution. Even then, like 1,000 is 1,000 squared is like only 1,000,000, which is like also won't take that long. But we'll do the n approach, just calculating the running sum. So here we go. Cool. So running sum equals. Can we do this in one line? I don't think we can do this in one line. All right, that's fine. Cool. So then you want to go for for num in nums. Running sum is an array with nums at 0. So if there's no nums, then we just return empty string, empty array. Otherwise, we are good to go. So then you just want to do running sum, next sum here. Next sum. Why am I typing? This is Python. We use underscores here. Next sum is the last sum we have in the running sum plus the number we're on right now. So that's running sum at -1 plus num. And then we want to append this to the list. Running sum dot next sum. And then we want to return running sum. Cool. This looks pretty good. Easy warm-up question. I got it wrong, but that's just me. What happened here? Why is my output? Oh, because I already included the first number here. I see. That's annoying. All right. Sure. If running sum else 0. We'll just do something janky like that. So, what? What is happening here? Oops. Next sum equals sum plus num. Shoot. All right, let's just solve the problem here. If running sum, let's do this. Then we use it. Otherwise, we just do next sum equals num. I'm not really concerned about cleanliness of code here. I'm just trying to solve the problem. Cool. Looks good. Let's test out some examples here that they give us. I don't think there will be any weird edge cases we really need to consider. So that's like maybe negative numbers. Yeah, I'm happy to submit this. Let's see how it goes. All right, it's easy. Yeah, pretty fast, pretty easy. Cool. Done. Done one. Let's do another easy one. Let's try to find a hard easy problem. Non-decreasing array. Not the very low submission success, so we'll see how this goes. Okay, given an array of nums with n integers, your task is to check if it could become non-decreasing by modifying at most one element. Okay. So it is maybe decreasing, and you want to make it non-decreasing? Sure. Define an array of non-decreasing numbers if the ith element is less than or equal to the I plus 1th element for every I, such that 0 is less than I is less than or equal to n minus 2. Huh? Right. So because if I is n minus 2, then yeah, that means that the n minus 2 element is less than or equal to the n minus 1 element, and n minus 1 is like the last index in your array. Okay, so we're fine. This is a pretty straightforward definition. Okay, 423. True. You could modify the first 4 to 1 to get a non-decreasing array. Interesting. Okay. Example 421. False. You can't get a non-decreasing array by modifying at most one element. Wait, what? Hold on. Wait, what's going on? 423 is, it's non-decreasing, which means it is, yeah, equal or increasing is what this means. Okay. So, interesting. So from what I understand of this problem, right. So you change this 4 to a 1, you're good. Yeah, and your numbers can be whatever. So if you change this 4 to a 1, then you have increasing. And here you can't change anything because you have multiple decreasing values. Right. So, you have 10 to the 4. What is that, like 10K? Pretty small input as well. That looks like they're acceptable of maybe like an n squared. We'll see. But from what I understand of this problem is you just need to check this condition for all I, and then you, okay, let me try to write this out. So the problem here is that you need to make sure your edit does make the array non-decreasing, and that you can only do one edit, right? So if you go through the array and you find a pair of numbers that is not decreasing, or that is decreasing, then you know that you must fix it. Otherwise, like if you don't fix it, then your array will have a decreasing section in it. So you just got to go through the array, look at the first, try to find the first group of numbers that is decreasing. And then you take a look at that. I think you will need to look at, so if you have something like A, B, C, right? And AB was non-decreasing. And AB are non-decreasing, are decreasing. Then you need to make sure that, let's say this is a special case where it's like in the middle of the array. So if A and B are decreasing, you need to be able to change, you can either change A or either change B, right? But if you change A or B, you have to make sure their surrounding elements are also non-decreasing. So let's say this was like Z, A, B, C, right? So if you change A, then you have to make sure that ZAB is non-decreasing. And then once this is non-decreasing, then you're good to go on onto the rest of the array. If you change B, then you have to make sure ABC is non-decreasing. And that is kind of the necessary move you need to do. I'm trying to think if the minimum you can look at is 4 items or 3 items. Because can you just solve this by looking at like ZAB? Because from here you actually don't know if I guess you can solve this problem if, given just ZAB, you can change the A and it will solve it. But if you're not able to change the A, it's still possible to solve the problem by going here and changing A, B, C. So I think what we want to do is actually do this in a very naive way. So we're only allowed to make at most 1 edit, right? So I think we can go through the array looking in chunks of like 3, like this. And if we see that this is there's a decreasing part in this sequence, we make the 1 edit on B, if we can. And then if we make 1 edit, we're done, right? And so we just exit out of the loop. And then we just run an audit on the array to make sure, okay, there's siren. We'll wait for the siren to pass. So here, once we modify B, we're done, right? We don't care about the rest of the array because we can only make 1 edit. And then we just audit the array and then see if it's non-decreasing. If it is non-decreasing, then we're done. So that's just like 2 pass. That's pretty simple. I don't have to think about too much stuff. So I will probably go with that. I generally prefer things that are like fairly efficient, that I don't need to think about too much when solving these problems, because the goal is to just solve it. But an interesting follow-up here, if my solution works, the 2-pass solution, is like how do you do it in 1 pass, which I think is where you have to check like the 4 elements or something like that. Something to note as well is you have the edge case of like A, B, C, ... where A is at the start, like kind of what they have, where you can actually change, if AB is decreasing, you can actually just change A. So that's like a worthwhile edge case to check. Otherwise, like, it doesn't really matter. And then you can just check in 3s. So let's just go ahead and solve this problem. So to start off, inputs n is 1, pretty annoying. So if length of nums is 1, definitely non-decreasing, we're done. If length of nums is 2, I don't want to think about this too much. So then if nums at 0 is less than equal to nums, return nums at 0. 0 is less than equal to nums at 1. Otherwise, now we have to address the array here. Oh, actually, no, this is not right, because we can actually make the change. So if nums is 2, we can actually always make it non-decreasing, right? Because we just change a number to whatever. So if it's not 2, let's see. What do we want to do here? So in the 4, 2, 3 case, yeah, you would want to change the 4, 2. So the first case to check is like, if like nums at 0 greater than nums at 1, try changing nums at 0. You have to try changing nums at 0. is there a situation where like this update is actually not the one you want to make? Let me think about that. I don't think so, right? Because here you have like the 4-2, right? You're pretty dead, but you could change the 2. Say this was like 4-2-5, right? Then you can actually solve this by changing the 2 to a 5 or a 4 or 5. But you can also just solve it by changing the 4. So that's that case. If this is like 4-2-2, yeah, you also want to change the 4. If this is 4-2-1, then you're dead anyway, so you don't really care. So yeah, in conclusion, you actually always want to change this because yeah, that's like, you'll have to change something. Right, that's what we were getting at before. So if nums at 0 is greater than nums at 1, set nums at 0 to nums at 1, and then audit, return audit nums is solved and nums. We can make is solved later. Otherwise, we go through the sets of 3. Okay, so for I in range, length of nums minus 3 minus, what is this, minus 3? So if you're at, if you have an array of 3, you want 0, 1, 2, length of nums is 3. So you want this to be 1, so yeah, that's minus 2. Okay, so so we want to look at 1, 0, 1, 2 here. So you say, what is this? If there's a decreasing element and it wasn't in the beginning, then it technically must be like B and C, right? Because you would have solved the beginning one. Yeah, so then you want to just make sure this should be like assert nums at I is less than or equal to nums at I plus 1. This is, yeah, I believe this is true. So you want to say if nums at I plus 1 is greater than nums at I plus 2, then we want to edit nums at I plus 1 such that we are okay. So we want to pick a number between, right. So this is what we want to do. Right, in the 4-2-1 case, right, but we're kind of screwed anyway. 4-2-3, right? Let's imagine it was like 1-4-2-3. So, you know, 1-4 looks fine, so you move on. You're looking at 1-4-2, right? So if I plus 1 is bigger than 2, I plus 2, you want to change I plus 1 such that it's less than or equal to I plus 2 and greater than I. So the change here, I feel like, is you just set it to nums at I, right? Nums at I plus 1 equals nums at I. You can just naively set it to nums at I. That will satisfy the non-decreasing condition, and then it's like you offload. So if this is not correct, then you're screwed anyway. So, but then if this is correct and like nums at I is also less than nums at less than or equal to nums at I plus 2, then you're fine. So it moves forward. So I think this is fine, and then you can return is solved. Right, so that's done, and then we want to return is solved if we didn't return already. Cool. I think this is it. Otherwise, we're good to go. Cool. And let's just define the solved self nums. for I in range length of nums minus 1. So return true. So if nums at I is greater than nums at I plus 1, return false. Otherwise, return true. I think this is good. Ooh, self-dot is solved. And then whoever is watching, if someone is watching, feel free to ask questions in the chat as well. I think that's why I picked live streaming as the medium to do this. Is you can ask questions in chat. I can try to answer them live. You can like provide suggestions in chat too, things like that. Julio, we're done. Okay, so let's try 1, 4, 3, 4. This should be good. Done. 1, 4, 3, 1. Oh, I got rate limited. False, nice. Let's try 1, 4, 3, 4, 4, 4, 1. I think like it'll just fail it, right? It'll just make the first change and fail it. 1, 2, 3, 4, 4 for 1. Ooh, I missed that edge case of if you're at the end, then you can change it. Tricky. All right. What is this? Let's just solve it in here. If I is length of nums minus 3, then you want to check if nums at I plus 1 wait, what happens here? Nums at I plus 1 is greater than nums at I plus 2. Oh, I see. So this is actually a special case of this problem. So if I is length of nums minus 3, right? Yeah, that should be correct. Then we solve it a different way. So if these two are different, then you're done. You just return true. So this is like modify last name. Otherwise, we do it the other way. Hey, we got it. Let's just rerun our test suite. That's another thing I don't like about the Leetcode basic environment, is that you can only run one input, I think. Let me try to run multiple inputs. I believe you can only run one input. Oh, you can run multiple. Nice. Okay, this is great. Yeah, because what I really like is setting up like a test suite. Usually if I'm like doing a coding problem or like solving an interview question, I will set up a bunch of cases and then always have my execution run all of the cases. So that, anytime I change anything to like fix a specific case, then, you just run everything and then make sure that none of the previous cases were broken, aka like basic regression testing. So let's do that here, since we have the ability. So we wanted like 1, 4, 2, 1, like 1, 4, 2, 4. Let's do like 1, 4, 2, 2. Let's do just 1. Let's do 1, 2. Let's do 2, 1. Let's do 1, 2, 3, 4, 3, 2, 1. Let's do 1, 2, 3, 4, 3, 4, 4. Let's do 1, 2, 3, 4, 5, 6, 4. We should be good here. This is amazing. Yes, we got it. All right, submit. Oh, I got the wrong answer. Wait, how did I get this wrong? Interesting. Okay. Oops. So 5781. Oh, because you're looking at 5, 7, 1. This was the edge case that I was thinking about. I tried to come up with, but I failed to come up with, I guess. That's annoying. So maybe you do have to look at 4. 5, 7, 1. No, I think you're fine, actually. So you only want to look at this if the element at I+1 is messed up. Right. So you actually, if this is true, you just want to continue. I think. Because then you get to 7, 1, 8, which is bad, right? We don't want to continue here because we could be in the danger zone down here. So we don't need to do the assert because we're correct here. What we want to do is you want it in the middle, right? And then you want to do this switch. So I do actually think you want to continue here. The 7 is greater than the 1, but you actually just want to look at 7, 1, 8. Yeah, all right, let's do this, something like this, right? So we actually want to change this up. So now we want if nums at I is greater than nums at I+1. Then you want to make the change. Huh? Wait. Because the fix could be to change the 7, right? No, the fix will never be changed to 7 in this case. Because the 7 is not wrong. The 1 is wrong. So yeah, my previous assumption was wrong. Okay, let me think about this. Oh, I didn't even start the timer. I'll do that for the next problem. Okay, if nums at I is greater than nums at I+1. Yeah, you have to look at it holistically. You have to look at these three. Wait, how come my previous solution didn't fix this? I like literally made the exact case. Oh, because it dipped below. So this the case we didn't fix is this one. So here you actually will lose, but that's fine. You have to change this 1, I think. You could change the 4 and try to win, but you can't really. But I think the 1 actually gives you more coverage if you change it to win, I believe. Cool. So let's try to change it now. So we have nums at I greater than nums at I+1. So you want to say Nums at I plus 1 equals nums at I, right? Is that it? Ooh. We got some gross looking results here. Show me the diff. Show me the diff. Case 3 is wrong. Where's my case 3? 1421. Do you actually have to look at 4 numbers, really? Oh, that's annoying. Yeah, I think you do. Dang it, I was trying to avoid looking at 4 numbers, but I think you have to actually do it. That is incredibly unfortunate. Okay, well, we're just gonna do it. Right, because you can't change a number without the context of the previous number, like in this case, right? So if you're only looking at these 3, you can't change the 4 without the context of this thing. But then you don't know if that's correct. Yeah. So you have to actually look at 4 numbers. All right, okay. So we decreased this. We actually want... All right, we're gonna change this up. Subarray goes to nums at I to I plus 4. Let's make this a little easier on ourselves. I plus 3. Is this enough? Can I like run a Python shell to like double check this? All right. Let me double check. Oh gosh, what happened? Oh, what the heck? Oh, I want to run cmd, not pwd. Let me run a bash. Let me double check. Oops. Ah, I thought so. Exit 0 to 0 is empty array, so this should be. Okay. Cool. Subarray is this, and then we want to go if subarray at -1, -2 is greater than subarray at -1. Do we really want to do this? No, because we still have to modify nums anyway, right? Oh, here we don't actually care. So. So we can just do this. But we want to continue. Fudge. All right, that's fine. I'm okay with this. Otherwise, we are looking at 4 numbers. Now let's just do it as nums. I don't like this. I plus 2 nums at I plus 3, right? This is what we had previously? Alright, we're gonna figure out what we had previously. We could have just done this the whole time. Okay. So that's done. Yes, I believe this is correct. Okay, so now we're looking at the group of 4, incredibly annoying. We gotta solve the problem for 3 then, which is also annoying. This is annoying, okay. So 425 also is fine, right? You can just change the first number. Yeah, that's fine, that's fine. That solves this, right? Because everything else works. Maybe like 447, the 441. But then 441 should get solved here, which it doesn't. Oh, fudge. Okay. Okay. This has gotten pretty messy. I can see why this problem is very annoying. Am I dropping frames? I think I'm okay. So we solved the problem of the first two numbers. Now we want to see... Is this even needed? Or can you just... Ah, whatever. I think they should work. Right, the diff... Can I, like, expand this? This is pretty junky UI here. Oh, what the heck? Which one's failed? 5, 6, 7... Oh, a lot of them failed. Oh, because of this part I didn't update it. But everything else works, which is good. Or like the weird cases here I added work, which is good. Okay, so now we're looking at 4 numbers. So we want to make sure wait, what? Oh, this is incredibly annoying to think about. Okay. Because this is actually also messed up now. Because we don't necessarily want to continue. Let me get rid of this continue here. I think we just are checking all the batches of 4 now. Okay, so how do we want to do this? You just care about the weird things, right? So I guess in the case where it works, we can just continue, like nums at 0, nums at I less than or equal to nums at I plus 1 less than or equal to, oops, nums at I plus 2 less than or equal to nums at I plus 3, I plus, I can't even type anymore. I plus 2 less than I plus 3. We're good. The weirdness happens if this is messed up or this is messed up. So I actually don't think we need this. I think we want to do something like if not this, then we do something, right? So this is messed up means, and you can assume the first 2 are correct because of that first case. So you're actually messed up here. Let's make that more clear. So if this is the case, oops, can't type. Oops, can't type. So if nums at I is greater than I plus 1, right, 1, 4, 2, 1 case, you want to see, can you change I plus 1 or I plus 2? I think it's the same logic actually in either case, right? Or nums at I plus 2 greater than nums at I plus 3. Then you want to change either 1 or 2, and then you want to return this solved. So this is what we want to do here. I think we're getting there. We're getting there. Okay. Can you change I plus 1 or I plus 2? You can do something like try changing I plus 1 and then try changing I plus 2. Yeah, we can give that a try. So what is that? Something like 142. To solve 142, you would want to change. You would want to check if you do like 112. I think this one has no good solutions anywhere, right? So then maybe it's not a good example. How was that? 5781, right? Here we go. So you look at 5781 and you say, what if I made this 5778? That's fine. What is the other option here? If you change I plus 1, how would you change I plus 1 to fix 571? You can't. That's impossible. But to try, you would do like 551, I think. No. What? All right, I'm like confused now. All right, so here obviously the change is to change I plus 2. What if you had like a 5178? Right, then you have like this is broken. This is broken. What? Then obviously you just change this one. What? Why is this so weird? What am I totally like forgot what was tripping me up before. I think because of the case, we like assumed that you had to change the 7, which was not correct. I think that's what was happening. Oh gosh. All right, well, you know, we're in this journey together. I think we just try to correct this, right? Trying to understand what's happening here. So if you're just looking at this, right? If you're just looking at 7 greater than 1 here, then the context is you don't. So you don't know if you change. Here you can't change the 7 to make it non-decreasing, but you can change the 1 to a 7. So I think that's really it. Because there's no other way around it. Maybe like 1711. Does this even matter? Anyway, we can just solve it and then think about it later. So let's change I plus 1. So pivot equals nums at I plus 1, nums at I plus 1. So the challenge is, do we change I plus 1? It has to be greater, so then you just change it to nums at I. And you say, is solved. You can just do the constant time check. If now nums at I less than or equal to nums at I plus 1 less than or equal to nums at I plus 2 less than or equal to nums at I plus 3, then we return is solved. Else pivot. And then you say pivot equals nums at I plus 2. This is change I plus 2. Pivot equals nums at I plus 2. I don't think we even need to do the pivot here. But nums at I plus 2 equals nums at I plus 1. And then we just return result, I think. So those are our only options, right? Huh? Wait. What happened here? Why does this look exactly the same as what was up there? That looked like a bug. Okay. Well, here we go. Ooh! What is incorrect? Number 5 failed? What is number 5? What did I say? Expected is false. What did I return? I returned true? What the heck? Okay. So we go into the loop, right? I would assume. We say if nums at I is greater than nums at I plus 1 is greater than nums at I plus 2, or nums at I plus 2 is greater than nums at I plus 3. So we come in here. We're at 1, 4, 2, 1. We'll try to change I plus 1 to 1. So then 1, 1, 2, 1. 1, 1, 2, 1 is not true. So we try to change I plus 2 instead. So we change I plus 2. Oh, why is solve this wrong? What the heck? Nums at I plus 1, you set it back to what it was. And then you store nums at I plus 2, which is the 2. Set the 2 equal to the 4. Oh, it's because I didn't unpivot, I think, here. No, that's fine. What? Is my check wrong? What the heck? Oh, this is going to be garbage to read here. Oh, okay. 1421 is wrong. Why? Why is this wrong? Because this problem is incredibly annoying. No? Oh, it didn't even go into std out. What the heck? Ooh, this guy messed up. Okay. Let's get rid of use, because you're not true anymore. Then let's fix the 3 case and then resubmit. So in the 3 case, we have 2 scenarios. If nums at 0 is greater than nums at 1, greater than nums at 2, we can't solve this. Otherwise, I think we can solve this. Right, so this covers strictly descending. 421 is not solvable. 423 is solvable. 422 is solvable. 424 is solvable. 3, 2, 4 solvable. I think that's right, actually. What did I get wrong this time? I got the last case wrong. Also got 5 is still wrong. What the heck? Interesting. Okay. The last case is also wrong. Ooh, this is annoying. Okay. Okay. We don't need subarray. If nums at I plus 2 greater than nums at I plus 3, and we're at the end, then this we can this is not true either. This is incredibly annoying. So you actually want to check it here, special case, right? Because no one is ever considering changing the last number, which you need to consider. Fudge. Okay. Annoying. But I think this is it. This is incredibly hacky, but I'm fine with it. So if you're at the end and you see, what is this? What would this case be where you can only fix things in the end? So it would have to be increasing and then not increasing, like this. Something like this, right? So maybe you can try changing, just change the last number instead as like an else if. All right, change 1. So I think this is actually cleaner. Let's try this. Oh, this becomes, no, you only try it once, or 3 times, so it's like 3n. Okay, cool. Now you try to change I plus 2, so you reset, you don't need this, and then you say, if solved, return true, boys. And then you try to change I plus 3. I plus 2. Fix it. You don't need the pivot anymore, actually, but whatever. If you're broken, you have to change something to fix it. So then you can just return false here. Oh my gosh, what is happening? 5 is still broken. And that last one is still broken. Why are they broken? Okay. Let me save all these test cases somewhere. And then let me just run the broken ones. And try to fix it. So let's confirm this is the one that's broken. Cool. How do we want to debug this? That's ugly. How do we want to debug this? I actually don't even think this is needed anymore. And that might actually be the reason why it's broken. Ooh, oh, did we do it? We didn't delete the line that was broken that we said we were going to delete. Oh, we did it. Did we do it, boys? Does this work for all of our previous cases? Oh! Wait, what? Oh, I thought I tested that case. What the heck? This case? What? Didn't I just test this? Oh, I tested 5718. Five one seven eight. You can change this though. Why didn't this pass? Fudge. This has become very naive. Wait, then this is also missing the case where changing the first one fixes your problem. Like 42222. This will fail on 42222. Right? Oh, fudge. It's true. Why? Why is this the case? Oh, God. All right. Try this YOLO attempt. Oh my goodness, that was annoying. Oh my goodness, we did it. We did it after like, I'm sure that took like 45 minutes. Like an insanely annoying amount of time. So this is the type of question I would never ask in an interview. Incredibly annoying. Like maybe there's a smart way to solve this, but it's very hard to think of. So yeah, I think here you just do it the dumb way and you just try to change everything. What the heck? Why? So I think the dumb way is actually you just try to change everything. I really think that's the case. All right, let me try to rewrite the solution. I think I know what the way is now. In fact, we don't even need this. We don't even need this. I think solution 2 would just be you just try to change everything, including the last element. Cool. I don't know if this is necessarily faster, but then it would be like n squared though, which is not good. So in the 5-1 case, you definitely have to change something. But then the next one you say it's like 1-7. In the 5-1-7-8 case, so now I'm like got nerd sniped here. In this case, right, 5-1 is busted. Everything else is fine. You can change the 5 or the 1, and you could win. In the 5-7-1-8 case, 7-1 is busted. So you either change the 7 or the 1, and that's it, right? So you only really need to look at if nums at I greater than nums at I plus 1. Then you try to change I or change I plus 1. And that's really it. And that's all you can do. And then you return. I think that's it. So you can only change I. Does this break anything? You try to change I to the number before it. You can also try to change I to that value. But then that's the same as changing I plus 1 to that value. So I think that's fine. Okay, let's try this. Change I. So you say, if I is greater than 0, try to change I. Old equals nums at I. I don't like this name, pivot. It's terrible. Old equals nums at I. Nums at I equals nums at I minus 1. And if you're done, we're done. Oops. Otherwise, nums at I equals 0. And then you do the same thing here. So you say, oh, this nums at I plus 1. Nums at I plus 1 equals nums at I. If solved, return. Otherwise, return false. I'm pretty sure this is all you need. Otherwise, I think you just return true. But whatever. Oh! I equals 0. There we go. Somewhat cleaner solution. Yeah, I think we can actually just return true back here, but whatever. Cool, we finished that problem. Let's go. All right. All right, we're just gonna do the daily challenge and then see if we have any time at the end for anything. So this is a program that Leetcode is doing. I'm sure if you're watching this, you probably know about it. So, it's like you have 24 hours to submit. And yeah. Wow, the stream is super delayed, but that's fine. So we're just going to do this one, I think, is the problem for today, merge intervals. Fun stuff, classic merge intervals. Given an array of intervals where intervals at I is an interval. Sorry, let me just check if anything's going on. It's crazy. Okay. Given an array of I given an array of intervals where it's just intervals in length 2, merge all overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. I don't want to do merge intervals, man. Why do we gotta do merge intervals? Merge intervals. Okay. So you have the basic n-squared attempt, right? Which is just you take an interval, see if all the other intervals are there, and you try to merge. I think that's n-squared, but I may be wrong. It might not be, because you could not intelligently figure out overlapping intervals, right? Like you could have 3 intervals that all overlap, but your n-squared approach wouldn't necessarily cover them all, I think. Yeah. So this is annoying. Can we do this in a smart way? All right, intervals length 10 to the 4. You have numbers are only up to 10 to the 4. So, you know, we could just have a big array of 10 to the 4, you know? And then see who's overlapping, you know? I think that's fine. That's a fine way to solve it in ON time with ON memory, is if you just create a big array of blocking at 0 to 10 to the 4, and then as you go through the intervals, you mark down the array, and then you see who overlaps with your array, right? Oh, you don't even need to do that. You just do it the dumb way. Yeah, what the heck? This is kind of dumb, right? You just make a big array of 0 to 10 to the 4, and then mark down slots that are taken up, and then scan the array again at the end, and build your remaining intervals, and you're done. What? This seems questionable. I'm questioning this approach quite a bit, but YOLO. Oh my goodness. Okay. Landfill. Cute name. Okay. 0 for ion range. Basically just like max of the thing, right? The max number of the interval. Okay. Max val equals 0. For I in intervals, max val equals max of max val I at 0, I at 1. 1 pass. Landfill, I in range, max val, plus 1. Alright, so we made our landfill. For ion intervals, you just go in again, and then you go for yeah, we'll just do it. We'll just do J for filler in range I at 0, I at 1 plus 1. Right, because you want inclusive intervals. You want like 1 to 5, so you fill out array at 1, 2, 3, 4, 5. So you go to 6. Yeah. Filler. So landfill at filler is 1. And then you just go through results equals empty list for I in range length of landfill. So interval start equals 0. Minus 1. Sure. Whatever. So if you go, if landfill at I is 1, and, alright, so if interval start is minus 1, then we want to say interval start equals I, right? And then, what is this? What is going on with indentation right now? Okay. Okay. If landfill at I is 0, if interval start is not equal to minus 1, then we ended our interval. So our previous interval was, our interval just ended. So interval end. So then we go to res.append interval start, I minus 1, and then you reset interval start equals minus 1. So we go through our landfill, right? We see a bunch of zeros. We don't do anything. We hit a 1. If interval start is thing, we're fine. We just set the interval start to the start of the interval. Keep going. Once we hit a 0, and we had already seen a 1, that means we filled up our interval, add it to the list, and then reset the interval counter, and then we return res. I think that's it. Hold on. What are the constraints here? If intervals, length of intervals is 1. Yeah, I don't want to deal with this edge case stuff, man. If length of intervals is 1, just return res. I'm not dealing with you. Otherwise, I think we just do it. Oh, syntax error. What? How is there a syntax error in this code? Okay. Huh? Interval start is not what? Interval. Interval. Alright. I think we solved this. Oh, we forgot to start the timer again. I'm sorry. And then we're not given invalid intervals, right? Yes, that's correct. Sweet. 1, 5. Right, so we have 1, 5. I didn't start the timer, so is that 1, 5. We want something like 7 to 11, and then we want like 4 to 8. So this should return one big one. We want a guy with no overlaps at all. So 14 to 18. We want someone with just 2 overlaps. So this is like 17 to 21. What happened here? Oh, because if I see. Just 2 plus 2, man. I think we're good. Ooh! Huh? No, oh, we messed up. Wait. We messed up. We can't actually do our solution. Dang it, I forgot. Because 4 and 5 don't overlap. Oops. Oh, that's embarrassing. All right, let's start the timer now, since we might as well start the timer. This is the second half of this problem. Hopefully this isn't loading on my screen. Yes, it is. Let's go. All right, second half of this problem. Let's see what we can do. So my mind immediately goes to tracking indices and filling up the landfill with the index of the number that index of the interval you're filling up. And then if you have a collision of indices, that's when you I guess like flood fill everything to the previous index value, if that makes sense. I just thought of another edge case I wanted to, a test case I wanted to test. 1 to 17, and then like 2 to 3. Also want to test making sure like order doesn't matter. 2 to 3, 1 to 17, and then this case that broke me. 1 to 4, 5 to 6. Okay. Yeah, so we actually want to insert based on the index. So something like, okay, so we're going through the array here. Intervals at I for filler in range thing. So if landfill at filler is 0, then just totally go ahead, index to fill equals I. Then you go landfill at filler equals index to fill. But if it's not a 0, that means someone else filled up this thing already. So that's like if you're doing like 1 to 5, 2 to 4, or like 2 to 7, right? Even if you do the 2 to 7 first, you're filling up the 1 to 5. Then you're overriding on the 2. Then what you want to do is actually reset your index to fill equals this value. And then you want to like use this value moving forward and backfill previous value. So I think this is what we want to do. How do we do this in an efficient way, though, is the question. So in theory, we can just do this with one pass, right? Alright, so let's backfill, and then let's use it moving forward. Use it moving forward, you don't have to do anything. But backfilling is where you want to do stuff. So let's do another for loop in here. Up to the current index we're at, which is filler. Right? Yeah. Then you want to do landfill at backfill equals index to fill. And then we're done. I think this works. Okay, did not work, clearly. Oh, I think this is also, oh yeah, this is messed up. Oh, okay. So we don't want interval start anymore. We want like interval ID equals 0. I mean, we can use interval start, but let's just do this. Interval ID is -1. Interval ID equals landfill at I. We do need interval start. I knew it. Not equals. Hold on, okay. So it's like you're going through this list. If you're already tracking an interval, then you want to keep track of when it started and what the current value is, right? So you're going through, you see a 0. Once you see your first non-zero, then you say, am I tracking an interval? No. Then I will start tracking an interval. If you are tracking an interval, and your interval value is the same, then you just keep on going. Not equals interval ID. Then you hit a new interval. So you want to do this thing. We found a new interval. Reset interval.start. Interval ID equals landfill I. Right. And then you need to go here and say, if you're going through, you hit a 0, and you had an active interval going, then you go interval ID equals -1. Oh, baby. Oh, okay, what happened here? All right, this is weird. This one, how did this even be one of, oh, because I'm returning some weird values in here, aren't I? Okay, we'll check that later. Okay, yep, something weird's going on. Okay, so we're going through, all right, let's print our landfill here. It's case 3 and the last case. Let's run case 3. See what our landfill looks like here. Oh, what happened? Our landfill is messed up. Landfill is a bunch of zeros. Oh, I messed up. That's what I want. Well, how did the code even run correctly? What the heck? Intervals at index. Index and range length of intervals. Index, oh boy. Index +1 is what we want. So we filled in this to 5.
the backfill is not good. Oh, the backfill, we want to take the previous value. I don't think we took the previous value. But, so this thing's still messed up. Okay. Okay. How much time has passed? 10 minutes, not bad. Okay, so for filler in here, if it's 0, you put in the index. Otherwise, index to fill is the filler. Backfill, and then this loop should be using index to fill moving forward. Don't understand. I mean, I know this is going to give me what I expect here, but... Oh, our case was too good. We got ourselves. So our backfill should actually not be... Yeah, so what happened here is your 2... Wait, this is weird though. The 4 should come in. 0, 1, 2, 3, 4. 4 should come in and hit here and start using 1 moving forward. It's not 0. Index to fill is 1. So you actually want to fill all the ones with 1. What? No. So you came in here, you started filling with 1s, right? Because your 4 to 8 immediately comes here. You start filling this in with 1s. You hit the 2, and then you're like, oh, it's 2 now. I'm going to backfill 2. But your backfill on 2 should be backfilling all the 1s. Oh, okay. So we need like a value to backfill or something. We did it! Congratulations! I think it was like the last case that was busted. Oh, we should stop printing. Ooh. Ooh. Oh, it's pending. Correct. Ooh. We messed up the last case. Interesting. Interesting that this didn't... So we filled it in correctly. We just didn't process it correctly. Okay. Aren't we doing this, though? Oh. We do want to be in an interval. Is what we want to do. And then interval ID is in landfill. Okay, cool. Cool. So. Okay. Hopefully it doesn't bombard things with prints. Our answers look right, which is good. Let's remove the prints. And I think we are good to go. Submitting. That looks about right. Oh, judging. I don't think we're gonna run out of time. We're like barely n squared. Huh? How did this get wrong? What the heck? Why did 0 to 0? What the hell? What? What the heck? Is this because it should be -1? I thought it would be -1. I knew it. I knew it. I was like, Python, you don't go up to that last value, even in the -1 case. Got myself. All right, this takes a while apparently. Oh no, it is as we feared, TLE. See, TLE presents a big problem because then we have to optimize this annoying guy, which I just don't want to do. All right, so this thing is clearly what's going wrong. Right? This is like at worst like n squared, right? Because if you have like 1 to 5, and then you have like 2 to 5, I don't know. I feel like there's like some weird stuff that can go wrong. Yeah, it's like if you have like 1 to 5, if you have 2 to 5, and then do 1 to 5. Then you will see as you go along that you can't like skip. And I don't want to do any like advanced skipping, so this is annoying. But what you can do... Alright, backfill we're going to have to do no matter what. This is fine. I think what we should do here is be smart about this index to fill. So using this value moving forward, because we overwrote, we know what the interval was. We can like do some optimization, but not that much. All right, I think I know what we're gonna do is we're going to build this almost on the fly. Because what I'm thinking here is if you have like 2 to 5 and then 1 to 5, right? 2 to 5 you fill up. 1 to 5 you start with a 1 and you start filling up with a new ID. And then you go to index at like the value of 2. And you see that it's filled up with another interval already. And from that point you actually know what the previous interval was because you filled it up. And you probably backfilled it or something, right? So then you know that this thing goes up to like 5. And you know what you have to fill up into with the current interval. So then you can just do the math there and like autofill it. Which I think is what I want to do. And from there I can see the solution that doesn't need memory. But yeah, I like, or it does still need, no, it doesn't need memory. Really. Yeah, so what I want to do is landfill, huh? So I want to do something like res by ID, by like interval ID is a dictionary. So assuming our backfill is done, so at the end of this filler up, we want to do like res by interval ID at like index to fill equals like this interval, like a comma b. Right? This is really what we want to do. So I think we're gonna just do this. All right. All right, I think I know what we're gonna do. We're gonna try to be smart about this here. So we're gonna say, obviously the start is just I at 0, right? The end is obviously I at 1 for this naive interval. So we're gonna go in. Let's refactor this. End plus 1. No, let's not do that because we need to change the values. So if we're just going in happily filling it up, right? We get to the overwrite time. We know the index to fill. We actually don't even need to backfill in this case. Let us just say let's just be lazy, right? So this is like where we want to optimize later if we want to, right? So now we know where to go moving forward. And you want to say if current end is less than or equal to, so like prev interval, prev interval, overriding interval, interval being overwritten, interval to overwrite equals intervals at index to value to overwrite minus 1, right? So we're looking at this interval we're overwriting is from A to B. If our current end is contained within. Huh? What is happening? Hold on. Wait, how does this solve the case of like big boy, little boy inside big boy? Because the 2, 3 comes in and it tries to overwrite the 1. Huh. Huh. What? I'm so confused. Okay, we can finish this. I have a hard exit at 8 p.m., so we'll see what happens. It's 7:43 right now. All right. If end is less than or equal to... so what we want to do here is, if our interval is contained within the previous interval, oh, then we're done, right? Then we're done. Because we're writing the previous interval's value. That's why it doesn't mess up, okay. Else. So if end, that means if end exceeds the previous interval, then we actually want to do oh, then we can just continue. Use this value moving forward. So done. So you want to say like if end is less than or equal to previous interval to overwrite at 1, then we can just break. This doesn't work. We gotta do the math. And break. Because we know what the end is gonna be. Oh, we have to fill it up though. Huh? Whoa, did this break? Hold on. Let me copy all the code, refresh the problem. I don't know what happened. Oh, is my internet down? Oh, don't tell me my internet went down. No, we're fine, we're fine. I don't know what's happening here. Okay. Weird. Correct. Ooh, this is not correct. Huh? What? Oh boy, okay. Can I even see submissions? Oh boy, okay. We are in a tough spot right now. Let's get him though. I don't think we actually need landfill anymore. I think I'm just gonna go without landfill, and just do the naive, the smart way of doing this. Oh, but you actually use it, so it's actually valuable to have. All right, this is fine. I don't need this. I think if our landfill is correct, then we're so this one. Oh no, that's right. Wait, what? 1 to 3. So how come the 2 to 6 didn't get filled in though? The 2. Ah, but this should be going until 6, right? I'm filling in. Oh, I didn't fill in the current value. Oops. And then it goes to the top of the loop, and then it should fill in because it's a 0. Oh, this is what we want here. Oh, no, this is also messed up. Hold on. We don't want the indexed values to overwrite. We just actually want it at values to overwrite. What? No, this is gonna be bad. I might need to come back to this later. since public life calls. What did we do? Hold on, we came in here. No, we don't actually want this. Yeah, we actually do want this. So if you're like 2 overriding 1. But you've already backfilled on the 2s. And you look here and you say, the thing is, this in theory makes the backfill thing correct, right? It should make backfill correct, the landfill correct. Mm-hmm. Why didn't it backfill? Why didn't it backfill? This should become 2. I want to fix all these cases, man. I don't have the time. This is really annoying. So this is correct. I think the thing here is weird. This is what we're trying to optimize, right? Is that, so now you're tracking everything in the 1. Start equals backfill. Start equals backfill is fine, right? How's 4 to 21? What the heck? Oh boy. Alright, this is not fine right now. Alright, what are we trying to do here? So we get the previous... This is just weird, right? Shouldn't it be value to overwrite? Because we are putting index to fill as... Yeah, we're doing like this dictionary at index plus 1. And so you're looking at like the previous index to fill value. Oh, this is weird. No, this is wrong. Because value to overwrite is you're saying it was like the current value that I'm filling in. So this is not actually interval to overwrite. This is the interval that you are joining. Oh, can I finish this? Join equals index to fill. Right, this is actually what you want to do. You're not going to delete anything. And then you say, if my end is less than or equal to interval to join, then I don't have to fill in anything because the interval to join you assume it's already filled in. And then you break. Yeah, I think this is good. I believe this should be correct. So 0 to 4, okay, this is still wrong. 2 to 6, 8 to 10, 15 to 18. 1 to 5, 4 to 11 is wrong. Dang it. Alright, in the 1 to 5, 4 to 11 case, what test case is this? Second test case. Why is it 2 to 6 here? Oh, it's already that value, so you don't need to fill it in. Oh, that's still wrong. Are my answers correct? Interesting, my answers are correct though. Alright, let's see if this is actually good. If it works, then... Oh, shoot, it worked. Let's go. Alright, we fixed what we needed to fix right on time, 8:01. Alright, I need to head out. Thanks for watching. Yeah, let me know in the comments if you have any thoughts about what's going on, any problems you'd like to see. Alright, see ya.